and we've got something that looks like this. And we want to know where is the car stationary. Now, how do we approach this problem? Well, just to see how we can figure out if it's standing still or not, let's zoom in on a tiny little piece of this graph. So let's zoom in on that little bit. So I'm going to blow it up like so. And basically we've got, if that's x and that's t, we've got a piece of the graph that looks like that. So that is if I just zoom in on that little piece of the graph. Now, can you see let's choose any interval on this. So let's say that's t initial, that's t final, that's x initial, that's x final. We see that in any time interval we choose, the position is changing. So everywhere on this interval, the car is not standing still at any time, right? Because its position is changing with time. Remember when Carlos or Xian visited their girlfriend for all of 70 seconds, they were standing still. Their position did not change with time. That does not seem to be the case over there, at least for that section of the motion. But let's look at a different section. Let's look, for example, what happens over here if I blow up this section. So I'm going to zoom in on that. So I've basically got a very broad curve like so, and time goes in that direction, position goes in that direction. Let's say we choose 2 points over there, from there to there. So that is T1, T initial, that is T final, that will then be X initial, and X final. Right, they're both over there. So even though this is not a perfect straight line, to a very good approximation, the position does not change in this time interval. It's very closely constant. Sure, there's a small change there, but we're getting somewhere. At least there's a very small change in position for this time interval. Now, can you think of what would happen if you were to make these 2 points come very, 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 very close together? We would get a better and a better approximation. Because right at this point over there, so right over here, there is what's known, you will do this in mathematics, as a local minima. But right over there, this position versus time curve is approximately perfectly flat. So how would we know? So where is this car stationary for a small period of time? Well, we could say it's approximately stationary close to either this local minimum, or with exactly the same reasoning, we could say it is stationary there at what's known as this local maximum. It's just where the graph has got its smallest and largest values for a certain interval. So we can say, well, to a good approximation, around those points, we get the smallest change in position for a small interval in time. And when you do derivatives and limiters in mathematics, you'll find out that if you make that interval as small as it can possibly be, you can actually make the statement that for an instant in time, right at that time that corresponds to the peak there, the car was stationary, just for one instant in time. So for the smallest time interval that's possible without the time interval being 0, that time interval is how long the car was standing still for. Now, if I go back to